position that we say every stakeholder has contributed to the value, but how it is that we determine how much is appropriated by a stakeholder is not known to us at this time. So this is something that this means that the role of managers and therefore of yourselves in this new employment market, which is going to give you a lot of judgment in making the determinations relating to these questions of appropriation and distribution. Put a lot of power in your hands, let's put it that way. Thank you very much.
Are you going? Yeah. Happy birthday! I didn't realize it. I was like, I got for you. Hang around.
I got I got a lecture.
Are you going to the mixer?
No. I finished at 8:30. I'm too tired. Gruppenarbeit machst.
Nee, wir sind da vorne gucken.
Dann halt nicht. This is not my sense of...
Sorry. We're gonna go faster. Maybe I'll just follow this together in front of the activities.
Can you do one down? Sorry.
Gosh, I hope this is not really intense.
Yeah, we kind of took your space, right?
I asked him, do not fear.
I am the Philippines better. How are you? Oh, you come on!
Hello, good evening, friends.
Well, you have to go. I just got here.
I'm gonna play GeoGuessr. Help with one. I was like, no. Stop it. Oh, you preparing what I always do. Gestern bin ich echt so nach dem Hausflug dann ausgestiegen, da war bei meinem Laptop keine Slides mehr
Am I stocked up? Thank you. If I run out, you'll get me tap
today, more than ever.
I appreciate it.
Yeah, for something here. I've heard that
So what?
Size questions for
Never
That's my worst way, like getting there.
Against her will. It happens to be really helpful. It's probably a great
I used to come to the education by I used to like my passport. Okay, everyone.
All right, thank you. All right, so we're a little bit late because the previous class was late. I might turn this off.
I'm going to turn that off. This is too much feedback. Okay, so it's good to see you. I'm excited to be teaching you finally. So let me just spend a few minutes explaining what we're doing today. So we've had a couple of weeks of climate science. How was it? Good? Hard? That sounds about right. Okay. So over the last couple of weeks, you should have been learning about how the climate system works, how we build models to understand the climate system and simulate it. And at the end of this, you should understand how we answer questions like how much has the climate already changed as a result of greenhouse gas emissions, and how do we expect it to change in the future. Right? And the typical outcomes have been things like global temperatures, sea levels, ice coverage, precipitation, and so on. But in themselves, these kind of outcome variables don't tell us a lot about how much climate change ultimately affects us as people, living in societies and working in economies, right? Just think about it this way. As many of you know, best estimate is that on current policies, by the end of the century, we would have 3 degrees of warming. Right? Is that bad? How bad is that? Listen to some people and they'll tell you that's a catastrophe, the world is going to end. Listen to other people and they'll say to you, well, 3 degrees is tiny compared with the difference between summer and winter, or the difference between Oslo and Singapore, right? So we need to ultimately understand what these physical changes mean for economies and societies. And that is where economists and social scientists come in handy, right? Because that's what we do. So this is the point of the course where we make that step from physical science into economics and social science. And the most natural way to do it is to try to trace through, well, what are the economic and social impacts of these physical changes you've been discussing? So that's what we're trying to do today. So hopefully you will have seen this slide from the recording, but just to give you, again, an overview of what we're doing today. So I asked you to read a paper in preparation for today, a paper by Colin Kelly et al. About climate change and its role in the Syrian conflict from the late 2000s, early 2010s. Okay, so we're going to start by discussing that paper, right, for about the first hour. I asked you at home to watch Mini Lecture 3.2, which is just helping you think about how to understand climate vulnerability, both across the world today and in the future. What we're going to do in class today is we're going to cover Mini Lectures 3.3 and 3.4, thinking about methods that economists use to estimate the impacts of climate change and the results of that. and we're going to do a second assignment. The assignment really speaks to mini lecture 3.3. I'm actually going to do it in between these two lectures because I think it breaks up the monotony of me talking a bit better. So we'll break it up like that. And then mini lecture 3.5 is a video that you can watch. You may have already watched it, but you can watch it afterwards. It's about climate adaptation. Okay, so that's what we're going to do. So I asked you to read this paper. It's a very well cited paper, a famous paper, maybe an infamous paper. It considers what possible role climate change might play in the Syrian conflict, and we're going to look in detail at the methods that they used in this paper and things that they tell us and things that they don't. Okay? So let me just switch to the assignment questions. So here we go. So this is the assignment. And we're going to discuss these questions. So the first question I want you to discuss is the following. So in the Kelly et al. Paper, there are two methods that they use to attribute the Syrian drought to anthropogenic climate change. What are those two methods, and what are the strengths and weaknesses of those? So I'd like you to spend about 5 minutes pairing and sharing with your partners, just discussing your reflections on those questions. I'm going to help you a little bit. I'm going to show you exactly where in the paper I'm essentially asking you to focus. It's all going to boil down to these two panels, panels B and panel C of figure 3, right? These represent two different approaches to attributing the Syrian drought to climate change. What are they? So 5 minutes, just have a chat with your neighbours, see if you can answer that question. What are they, these two methods? And what do you think their strengths and weaknesses are? Okay, off you go.
My mom the armpits, you go supposed to be uniform. You know what I'm talking about? Oh, hi.
I guess the first like observe motivation
Quite a large sample. 16 models.
I try to draw you in.
Yeah, I didn't know you. My understanding of the times and CO2 that makes
One of them is also a very cat.
Yeah, it's
Okay, so yeah. So model in and
So, irgendwie jetzt die richtigen Worte, aber was soll das
I was giving like Arabic, like models. That actually I imagine that a cautious, highly cautious.
Okay, es geht nur in eine Richtung. Aber damit das halt
Sorry.
And then autonomous copyright.
There's no such thing. I don't believe in that concept.
That's great now.
2 more minutes. 2 more minutes.
Models, welche was
how do you
I think there was also issues with the real trustworthy.
Okay, let's see what you came up with. Okay, so panel B, method 1, what was it? Yeah, so can you say a little more about how this works?
So they took the running 3-year means of the winter precipitation and then regressed that on CO2. And they said that's the anthropogenic effect, and the residual is just the variance.
Exactly. Excellent. So we could call the first approach, they call it observational, I would call it statistical. So they ran a regression. Okay, that's going to be an issue, that's my laptop telling me. I'll deal with the settings of that in a little bit. So they ran a regression. I'm going to assume that you all know what a regression is. I'll explain a little bit now, but if it's an unfamiliar concept, I would suggest to get on ChatGPT or Claude later and just have a chat about it, okay? Basically, they first had to define a measure of drought. Right? And this is not a completely straightforward thing to do, right? But their measure was the 3-year running mean of winter rainfall. Okay, so you measure rainfall in year T in the winter, rainfall in year t plus 1, rainfall in year t minus 1, take the average of those, you have a running mean. Okay, and let's just call that r at time t, and then specify a regression model, the simplest one that we can think of really in this setting, right, which has an intercept, is a function of the atmospheric CO2 concentration, and there's an error term, okay? And the hope is that by regressing winter rainfall on the atmospheric CO2 concentration, you basically capture the anthropogenic part, right? The part of the influence of climate change, man-made climate change on drought conditions in the Fertile Crescent. And anything that's not in there we could call natural, right? So then we can use the intercept and the errors to recover. So we basically take the CO2 out of this, and we'll have an estimate of the distribution counterfactually, right? In the absence of warming from CO2. Right? Now, if you are unfamiliar with the idea of regression, basically the idea here is that we first construct a scatter plot of winter rainfall against CO2, and we might see something like this. And then we are essentially trying to fit a straight line through those observations, which minimizes the distance between the line and the observation, so the line of best fit, okay? And that would be something like this, and it would have an intercept of alpha, yeah? And the slope would be the beta, yeah? And so it's really very simple. That's the first approach. We're just using observations of winter rainfall in the region. We're taking atmospheric CO2 as a sort of catch-all proxy measure for man-made climate change, and we're using that very simple regression equation to recover two distributions, right? The situation in the Fertile Crescent as it is, as represented by the red distribution, and the counterfactual situation if the climate had not changed, as represented by the blue distribution. I'll come back in a moment to interpretation of these charts. Let's move, though, to the second approach. So what is the second approach? What was the second approach, Lisa? Yes.
It doesn't use the observed data, but it uses outcomes from climate models.
Yeah.
So they use different models from the IPCC.
Exactly. So this it might be a bit more familiar to you because these are the kinds of models that you were exactly talking about last week. So we can go into the IPCC repository for climate model runs, and for each of the 16 big Earth system models, we can recover a reconstruction of the historical record in this region. And we can do that, and then we can go in there and we can also get a run where the model is run without the influence of man-made greenhouse gases. Okay? So two differences then. The first one is that instead of using a statistical model, we're essentially using what, for you economists here, we might call a structural model, right? We're using a physical climate model, so we're no longer trying to capture this relationship statistically. We're using these detailed process-based models based on the laws of physics, such as they are. And we are using these models to construct both the current climate as it is, the red distribution. And we would do that by picking climate model runs that include man-made greenhouse gases, because that's got us where we are. And then we would compare those to what you get from a runs of the models without the man-made greenhouse gases, which is a sort of model constructed counterfaction. So we've got two different methods, but they're both trying to get us into the same place, right? If we're trying to attribute extreme weather events to climate change, we are trying to compare two probability distributions, right? One with the climate that we have, which has been subject to forcing from greenhouse gases, and the other one, counterfactually, with the pre-industrial conditions, without man's influence. The reason that we're comparing probability distributions is, of course, because extreme weather events are uncertain phenomena, right? They can happen anyway. There have been droughts in the Fertile Crescent before, climate change or not. So the challenge here is always being able to say that this extreme weather event happened because of climate change, or didn't. Or if I put the question a little bit more precisely, how much more likely was this event due to climate change? Well, that comes from comparing these two distributions. The outcome variable we care about here is drought, right? That's measured by winter rainfall. Climate change shifts the distribution to the left. That means it makes conditions drier, right? If we were thinking about heat waves, we'd have a different situation. We'd be looking for a shift to the right on some kind of temperature measure, but this is drought, so we're looking for a shift to the left. Yeah? So we're looking for a shift to the left. We see that. We see that with both methods. Both methods are landing us in a very similar place. If we're going to make a statement about how much more likely an event was due to climate change, we first need to pick a point on the horizontal axis here, define that as being a drought of given severity. Then we can read up from there and figure out how likely that event was without climate change. So if I pick this middle dashed line here, and I read up from there to look at what the probability distribution says without climate change, okay? And that is telling me that that's got a probability of about 1 or 2%. Right? So to have 3 winters on average this dry, it's about 2% likely without climate change. With the shifted distribution because of climate change, I read up further to the red distribution, that's telling me that's about 4 or 5% likely. Okay? So it's become roughly twice as likely because of climate change. So that's how they do event attribution in this paper. And you know, whenever you are reading about an extreme weather event, like say the fires in Los Angeles or the floods in Valencia or the drought in the Fertile Crescent, and you hear a statement like this, you know, climate change made this twice as likely, the basis for that statement is an analysis like this. Yeah? You have to work out how likely the event would have been without climate change. Then you need to construct a counterfactual probability distribution. And you need to work out how far climate change has shifted it. For that, you need either using a statistical technique or using climate models to construct an alternative distribution which maps onto the climate that we have. So, briefly, in terms of the advantages and disadvantages of these two different approaches, what did you think? We're just going to dig a bit deeper into methods here. So what's good about the statistical approach?
You don't have to rely on the models, which have some drawbacks, which we discussed in the past weeks.
Yeah. So certainly, if you've had 2 weeks of David Stainforth, you'll know that the models have weaknesses. Okay, and so we don't need to rely on them. We can rely instead on more strongly on observations. Yeah, that's definitely an important one. Yeah.
There's like actual instrumental record as well.
Yes, exactly.
The data you would actually have.
So you know, the first point, I suppose, was more accurately to say that this method is good because it's not that one. That was basically your point, right? And your point is additional to that, which is that here we're actually really using the observational record, because actually with the climate model we're not. This is not the observational. The red one is not the observational distribution. It's a model reconstruction of that. Okay? It could be biased. Yes.
I'm not sure, but I think implicitly with the statistical approach, we assume sort of a same functional form. And I believe with climate models, we could like allow for like more fat tails, I believe, but I'm not sure.
Yeah, so I think you've very well covered the issue with the possible disadvantage of the statistical model. I mean, like any statistical model, this is subject to misspecification, right? It could be the wrong statistical model, and certainly this is the simplest statistical model that you could possibly write down in this setting, really, right? This is what you would do in week 1 or 2 of a multiple regression course, right? And if you're on GY428 and you turn this in as your term paper, then you're not going to do very well, right? But so there could be issues. There could be in general, we could think there might be omitted variables bias, right? There's certainly, if you look at the temperature, if you look at the rainfall record, there's clear evidence of serial correlation. It goes in cycles as well, and that simple model doesn't deal with that. But in general, the statistical model might be biased, or even if it's not biased, the errors might be underestimated. That would be the consequence of not dealing with serial correlation. So we might want a more sophisticated statistical model, but what I would say about this, though, to you as econometricians, is that as econometricians, we're often dealing with harder social science type problems where omitted variables, bias, and reverse causality are more worrying. In this kind of physical science setting, I'm a bit less worried about that. First of all, there's no reverse causality. Nobody's pretending that dry conditions in Syria materially affect the atmospheric concentration of CO2. You don't need to worry about that, right? That's one of the first things we worry about as statisticians, reverse causality. Do we need to worry about omitted variables bias? Maybe, yes, but if the purpose of this exercise is simply to parse the natural component from the anthropogenic component, then as long as, this might be okay. Okay.
I think adding to this, it's good that they use the global 3 years running mean. So because it's like global CO2 concentration is like more exogenous variation than just, for example, you're only using the local CO2 concentration. So that's like something that like not completely kills energeticity, but somehow like tackles it. So you to be like more sure about the estimates. So
exactly, great point. And so, but let's speak in favor of the other method, right? So what is good about why do climate scientists would normally go for method C, right? Panel C, this approach, method 2. Why would they do that? Yes.
Well, one thing I was thinking is that the climate model doesn't make the assumption that the natural state will stay the same without CO2 emissions, which is a crucial assumption that the statistical model is making.
Yes, you're right. Yes, indeed. Yeah, this model literally assumes that without CO2 forcing, you would have a sort of stationary distribution of the natural climate. Yes, so the climate model doesn't need to do that. And why?
Based on theoretical understanding?
Exactly. So climate scientists like climate models because they are based on the laws of physics, because they're based on fundamental physical understanding, right? And that brings an added dimension to things compared with the statistical model. It doesn't take a judgment. It just relies on the relationship being teased out. Yes?
It's also not relying on data that would be weak and also doesn't go very far back. The earlier data is less reliable, whereas the climate model is.
Yes, that's right. But we could flip that around. So one of the things that David probably talked to you about last week is the fidelity of the models at fine scales, okay? Whether they do a good job of simulating regional climates. So although the statistical model relies on observations, which don't go back very far and could be measured with error, we know the models don't do a great job of simulating local climates. And in fact, in the paper, there's a sort of a rather tersely worded sentence which says something like, just let me find it here. So they talk, so this is the paragraph at the bottom of page 3244. Let me just show you that so you can see what I'm reading. Okay, so this is the paragraph where they describe the second approach here. You know, we used 16 models to construct distributions. Rather than removing the CO2 forcing, we compared the historical and the historical natural runs. That's the two types of model run I was talking to you about. So the former include all the forcings, the latter only the natural forcings. And here we are, so that in this analysis, the models were normalized to the observed CRU mean and standard deviation. What CRU is a rate set. It's basically the observations. What they're basically admitting is that the models are out of whack with the actual observations. So they basically just do a little correction. Shift them all, so they map onto the observations, which is good, right? I think that if you're going to rely on the models, that's a good idea. But it also shows the limitations of the models at simulating local climates.
The models are reliant on the observational data to be fixed. Why are we trusting them when we don't have that observation?
What do you mean?
We don't have the observation of what would have happened without CO2 emissions, but we are relying the models. We rely the models to project something correctly, even though when we do have the observations, we assume.
I see your question. I think it's a really good question. So basically, the only thing we really observe, assuming the observations are accurate, the only thing we really observe here is the red distribution in panel. This is the observed distribution. Okay. And then we want to construct a counterfactual. Neither of the counterfactuals are, by definition, observed. Right? So we've got two different ways of doing it. For the model, we have the additional problem that we need to make the models close to the reality, right? So we do that through this bias correction, as they call it. Just because the models were off on the observed distribution doesn't mean I would say that their counterfactual is worse, right? Because I think there are strengths and weaknesses of these two approaches in producing a counterfactual. Would be my answer to your question.
So off, but not enough to make it a real problem.
Well, there are some reasons for thinking the models could produce a better counterfactual, and some reasons for thinking the statistical approach will do it. We don't know. Yes.
So in this specific case, should we be concerned about also sample size for the statistical model?
It's not large. Yeah, it's a sort of typical time series. So we've got about 80 observations, and indeed the p-value for the regression is not great. I think it's a significant at about the 95% level. Okay? But I think this is the right moment in this discussion to take a step back though, and decide how convincing we think this analysis is. Right. So we've been picking strengths and weaknesses in these two different approaches, but ultimately, they're both saying very similar things, right? They're both saying that climate change made the drought that occurred in the Fertile Crescent just before the Syrian uprising more likely by about a factor of 2. And that is reassuring. It's convincing that we've managed to get there through two very different methods. Okay? So I would venture that this part of the paper is fairly convincing. Yeah.
But on that, since we normalize the distribution of the model on the observational data, is that not like
they're not fully
shooting a moving
independent?
target? Like in that sense, if then after doing that, the distributions look more or less the same, I would say that's something I expect if I normalize it on that mean and the standard deviation, no? Or is it really about the relationship between the observational and the counterfactual?
Good question. So the correspondence, the similarity of the red distributions is assured because of this correction being made. So the difference between the red and the blue in these two cases, the fact that it is very similar is not baked in by the assumptions. Okay. So that is reassuring. Okay. And so I asked you to think about how event attribution like this can be made more robust. One of the main ways to do that is to use multiple methods of attribution. Or if you're only using climate models, to use as many different models as possible. So this study does well on that. It's two different approaches, not completely independent of each other, but quite different. And within the model approach, all 16 of the big models collected by CMIP, right, the IPCC model intercomparison exercise. So this part of the paper is pretty solid. Okay. But so far, we've only considered the effect of climate change on the drought. But this paper is not just about the drought, right? It's about the conflict that followed the drought in time. So, who can tell me about the methods they use to attribute the conflict to climate change? Just looking for some new hands. Somebody who's not contributed yet? You've read the paper, I assume. Slightly guilty faces, maybe. What was the method they used to attribute the conflict to climate change? I'll give you a clue. It's a bit of a trick question. Yes?
Well, it was mostly analysis comparing to other countries in the region and comparing to their own countries in different periods of time, and analyzing different factors that were impacting their economy and their social aspects that were related to the drought itself.
So was it a research design that you recognize?
It would be like more like I forgot the name of that, but when you compare different states and the same country many times, I forgot the name.
I think you're being generous to the study. Yeah?
I think what they tried to do a bit with the borders of Turkey and Iraq is a bit of a discontinuity design.
Yeah, I mean, yeah, they didn't formally do a regression discontinuity, but they sort of invoked those ideas. Yeah.
They're trying to list a range of possible direct and indirect factors, but it's relatively speculative and there is no data supporting, no quantitative data supporting.
I think it was interesting that they ended with an anecdote from a participant saying, of course it is, as sort of a final thought of, well, we might not know, but here's somebody who can say definitively, well, that's one person.
Yeah, so I said it was a trick question. That's because there isn't really a research design to this part of the paper. Okay. A word you could use to describe this part of the paper is narrative. It's a story. It's going through things that happened after the drought, which are plausibly connected to the drought, right? I mean, it is highly plausible that the Syrian drought contributed to the uprising. I'm not denying that. But what I am trying to get you to do is distinguish between this sort of solid part of the paper that does attribution of a physical event to climate change from the rest of the paper, which is sort of telling a story about how this drought may then have led on to Syrian uprisings. Why would that be potentially a difficult story to tell?
I was thinking, because there is not a specific causal framework, like a place where we can do like a natural experiment that is not like affected directly by the drought. Like you can isolate the effect of the drought because there is not like counterfactor Syria per se.
Yeah, and so, well, right, so we can't do a randomized control
Yeah,
trial when we go into a country, randomly pick a country and start a civil war. Compare it with a similar one where we don't have a civil war. But more generally, so why would we, why are you worried about causality here?
Because I think
Isn't it obvious that droughts cause conflict?
No, it's like the mechanism is not very clearly stated. It's just attribution. It's more just correlation versus causation, right? Like the narrative that they say.
Yeah, but this point's probably very obvious to you. But just for everybody's benefit, like, why are we worried about the difference between correlation and causation here? Surely droughts cause wars. Surely there's no doubt about this, right?
There are many other factors that are not included into this analysis. Like obviously, Syrian had a much more authoritarian government. There was possibly a repression in the country prior to that. So if you, with this sort of analysis, continue, you would assume that a majority of the causal impact is due to the changes in climate change, when there are much more serious things that could have caused the war beyond the changes in climate.
Exactly, right? So there are confounding factors out there which also cause civil uprising, like the existence of an authoritarian government, the existence of a war across the border, applying refugee pressure on the country. The fact, thinking even just about the physical environment, the fact that long before this drought, the groundwater was already being depleted by unsustainable farming practices. So we're in this world where there are these other factors which could plausibly explain the conflict. And we would ideally have a method for controlling for them. And this narrative, while suggestive and plausible, does not go that far. It's a complex causal chain, and I really want you to go away with that point. It's a weather event attribution is fine, but to go from climate change to the economic and social consequences involves a longer causal chain with more confounding factors, which is more difficult to deal with.
If the authors had left it with something saying like, we have found that drought conditions can lead to conditions that are susceptible for forms of civil unrest, including that, and leaving it at that, would that have been a much more relaxed way of saying it?
I think if I'd been a referee for this paper, I would have said to them, I like what you've done, but I would prefer you to just present this as a weather attribution study with a discussion at the end, which is very explicit about the fact that it's waving hands. But I mean, that makes the paper interesting. I'd like to know all these possible mechanisms for how the drought caused the conflict. But just don't pretend, please, that you've proved the two are linked. Okay.
Maybe also the fact that drought is a very slow onset shock rather than something like a flood, which maybe could have more.
Yeah, so you could. I mean, actually, that gets us on to the next question. So that can we think of a way that you could do this, right? So I think we've already been feeling some of the interventions for the kinds of natural experiments. I mean, we've ruled out an RCT, right?
Yeah.
We're not going to do that. I mean, well, we could do something in a sort of an econ lab, right? We could get some undergraduate students in business and economics together, and we could have one really hot lab and one that's not hot, and see if they start fighting. But more seriously, we're looking for natural experiments, so things like sudden events can give us a kind of an event study type setup. There are studies out there like that. There are also qualitative methods that we could use to investigate this issue, so we don't have to do this quantitatively. So can you think of qualitative ways we could do this? Those of you who are more into qualitative methods? Looking for some new hands? Otherwise, I'll be happy to have old hands. Qualitative methods, anyone?
Yes. Maybe reactions to policy interventions that we put in place and regards to that.
So tell me a bit more about that. So what's the idea here?
So if there was some kind of like moratorium on payments or something like that, how the public reacted to it, or whether there was a lack or something like that, how people reacted to that, and how that could have led to unrest.
Yeah, so but how would we measure the reaction? I suppose that, like, what is the kind of research you're thinking about here?
So if it's a qualitative research, maybe if there was some kind of rioting, protests, or something like that.
Yeah, and so, okay, so yeah.
Maybe some interviews or looking at the news historically and seeing how much has come like a conflict in the news.
Yeah, so we could do some interviews. We could talk to people. We could get them to document their histories. We could look at, say, I mean, one of the claims they make in the paper is that the drought caused rural to urban migration. So we could go into urban refugee and migrant communities, and we could do sort of participant histories. We could ask them, why are you here? Was the drought part of the reason why you've come? How important was it compared to other factors? So, I'm just trying to get you to appreciate that there are, causality is not just to preserve of quantitative methods, right? We could also have done a better story of, a job of demonstrating causality with qualitative methods. Okay? But we should at least have a more serious attempt to do it. Okay, I am going to wrap up the assignment here and give you a little break in a minute. What I have been trying to do here is to illustrate to you how climate event attribution works. So what is the science behind these statements like event X was Y% more likely because of climate change? And in addition to that, and for that I'm very grateful to this paper, I've also started to get you thinking about the extra difficulties when we start to think about economic and social systems and the longer and more complicated chain of causality that links climate change with economic and social outcomes. Okay, I'm going to give you, well, let me ask you a question. Would you like 2 10-minute breaks or one longer break and just a short one now to get your attention back? So, show of hands for 2 10-minute breaks. Show of hands for 1 20-minute break and a short break now. Oh boy. I think the 2 10-minute breaks actually win. So let's take a 10-minute break and start again at 5 past.
This is recorded late night.
Like a well-designed,
It's like a lecture, but
I'm too shy to
Right now, like, I'm taking well, the church one, so like kind of things that
Styles, Wednesdays, and it's 3 hour lecture seminar in this room.
So you've got like mentors, like probably you've got
I'm already struggling to set these units, and now they're taught in the same way.
I don't like
Oh, really? Guys, oh, yeah.
What's my reason?
You gotta remember, it maybe I don't know if LSE does it like that. Email.
Well, they did it for COVID.
And you still got better grades. When he sees all the spelling mistakes, he's gonna know. How did someone misspell the course?
I had the same like
We put in my counter right now. That's locked in,
I don't get the and I prefer 9 and 10. Well, 9. I would like 9. I get my 10. If I don't get my 10,
similar vibes.
Not good
I'm done. American way, we organize it. I saw you too.
has like things
great things.
Okay, so we started to talk about estimating the social and economic impacts of climate change. We were focused on a single event, the Syrian uprising. Now we want to go much broader and look at attempts that economists have made to estimate the overall cost of climate change. Okay, so a much bigger question. I'm now going to be in lecture mode. It's going to take me about, let's think of a number and add 20 minutes, Simon. It's probably going to take me the better part of the hour, okay? And then we're going to go into another group-based exercise. Okay, so that just gives you you can cope with me if you know I'm going to stop eventually. So, what are the learning objectives of this mini lecture? So I want to explain to you the principal methods that economists have used to estimate the impact of climate change. And I'm going to ask you in the assignment to think about the strengths and weaknesses of these. And then after that, I'm going to tell you the results. A disclaimer, right? I am not. 1 hour is not going to make you an expert in any of these methods. Okay, so it's just intended to make you informed users of the information from these studies. You understand how the estimates are produced, broadly what the strengths and the weaknesses are. That is the aim of this. Okay, so why would we even want an estimate of the economic impact of climate change, right? To the economists here, that would be obvious. So of course we want to do that. To the non-economists here, it's not so obvious, right? This quote from a paper by Richard Toll, I think, captures it quite nicely, so I'll just read it to you. So he writes, "The impacts of climate change are many and diverse. It's very difficult to make sense of the many and different effects. Crops hit by worsening drought, that's a bad thing, right? Crops growing faster because of carbon dioxide fertilization, that's a good thing, right? So more CO2 in the atmosphere, CO2 is needed for plant growth, so that's good. Heat stress increasing, bad. Cold stress decreasing, good. Sea levels rising, bad. Increasing energy demand for cooling, bad, although the cooling itself is very useful. Decreasing energy demand for heating, good. Infectious disease spreading, definitely bad. And species going extinct, almost always bad. Although wasps and locusts, I'm not so sure. Thus, he writes, we need aggregate indicators to assess whether climate change is on balance a good thing or a bad thing, and whether the climate problem is small or large relative to the many other problems that society faces. So for that, it would be good if we could have an aggregate metric of the cost of the impact of climate change, and one aggregate metric for that is economic cost. Next week we can talk a little bit about alternative measures of climate impact that are not economic. But the economics toolkit is useful for this kind of thing, right? Because we can try to compare very different kinds of climate impact on a common basis of money and cost. The traditional use case of this kind of work is cost-benefit analysis, which I'll talk about next week in the climate setting. So the traditional use case for this kind of work is, how bad is climate change going to be? How much do we have to spend to fix it? Is it worth it? how aggressive should we be on reducing emissions? That's the traditional use case for this kind of work. It's, I would argue it's a very important use case. But it's not the only use case for this kind of work anymore. And you know, to some extent, we might argue that we now have international climate goals, so we don't really need to have this discussion anymore about whether it's worth fighting it or not. But you know, now the interesting new use cases for economic cost estimates are in places like ministries of finance and central banks. Right? The ministries of finance, for example, are interested in what is climate change going to do to our country's fiscal sustainability? What's it going to do to growth? What in turn is that going to do to tax revenues and public spending? How do I need to factor climate change into our tax and spending plans? Okay, so that's another use case. In the area of central banking and monetary policy, a use case might be, what's climate change going to do to inflation? What is fighting climate change going to do to inflation? Should we expect it to put downward or upward pressure on inflation? What do we need to do to interest rates to deal with it? So there are, as climate change stops becoming a problem, a hypothetical problem of the future, and increasingly a problem that we've got right now, we get an increasing number of use cases for economic analysis. Okay, so hopefully I've made the case for this being important. And then now, what are the different ways that economists are trying to do this? Well, I'm going to work with sort of a typology with 4 elements. You can see minor variations to this in different publications, but I think it mostly sticks to this quite closely. So I'm going to explain what these 4 methods are, so I'll just read them out here. First one is the enumerative approach, which is related to using process-based simulation models from the natural sciences. I'll just say that. The second one is the statistical approach. It's going to have a lot in common with the things we talked about before the break, the regression that we ran for Syrian drought and CO2. Computable general equilibrium, or CGE models. And lastly, but not least, expert elicitation. So what I'm going to do is I'm just going to go through each of these and try to give you a sense of what this involves. So we'll start with the enumerative approach. The oldest approach to estimating the economic impact of climate change. What does it involve? So it's called enumerative because it takes a sector-by-sector approach. Okay? So firstly, you need to define a set of, loosely speaking, sectors. Another word for this or phrase for this might be impact categories. Okay? They don't match perfectly onto economic sectors in standard classification systems like NACE or I forgot the other one. Anyway, doesn't matter. But they are sort of different broad climate impact pathways. ICB, right? There are different impact pathways, and for each of these, we're going to try to estimate the economic cost, and then we're simply going to add them up. That's where the idea of enumeration comes from.
Yeah. So when we do these analyses, are we ignoring the possibility of adaptation?
No.
So we need to make a prediction on how they adapt?
Yes, in principle, yes. And that is one of the things that I hope you're going to talk about in the discussion later, the extent to which these methods are able to think about possible adaptation to climate change. But the short answer to your question is we absolutely want to try to account for that. In old studies of the impact of climate change on agriculture, there was a problem which became wonderfully known as the dumb farmer syndrome. And these were models that basically said, well, the climate's changing, the conditions are getting worse for particular crops, but in the model, the farmer would come out every spring and plant the same crop, right? And farmers are not dumb, they don't do that, right? They change the crops they plant, right, if the climate changes. So we need to try to deal with this as far as possible. So, basic idea of enumeration. Define a set of sectors that are impacted by climate change, quantify the costs in each individual sector, and add them up.
Are these all like distinct, or like there's no overlap between them?
This approach is going to treat these as being distinct, and it's going to think that it's reasonable to add across them. And if you've got some thoughts about that, keep them in your head for this stuff. So that's part of the enumerative approach, this idea of adding up sector by. Just let me say one thing and then I'll come back. The other part of the enumerative approach, sort of, you need to kind of understand a bit the history of how this method came about. Right? The other part of this approach is that for each of these sectors individually, economists are basically going into the relevant science literature, getting an estimate of physical changes caused by climate change, and then just multiplying them by appropriate prices. Okay? So in the case of, say, agriculture, it would be, I'm going to ask an agronomist to estimate the impact of climate change on crop yields, and then I'm going to multiply that by some kind of estimated crop prices, and that's going to give me monetary value of lost output. More interestingly, in the area of health, I can go into the health literature and get some numbers for the impact of climate change on mortality or morbidity, and then I can multiply that by the value of a statistical life, or the value of a statistical life year, which is like the price of life. Right? Now, if that sounds like a mind-blowing concept, you'll be doing the value of statistical life in GY427, right? Okay. And I ask you to consider the history of this because, you know, when economists first started working on climate change 25, 30 years ago, there weren't any other studies. So they naturally went to the science literature to try to understand like what the physical changes are going to be. And they thought, okay, we're just going to apply prices to those. Now I had a couple of hands. You still want to?
No, I'm okay.
And you talked about the cost, but I can imagine that there can also be benefits in certain sectors. Do you take those into account as well?
Absolutely. So these approaches are all agnostic on whether the effect is positive or negative. Now, where do the natural science estimates come from? Well, they can come from various methods, but a lot of the time in the natural sciences, the estimates are coming from sort of process-based simulation models, right? So it can come from statistical work as well, where the boundaries start to blur a little bit between these different methods. But, you know, for example, in the health literature, in a lot of epidemiology is based on statistical models. But in other impact sectors, we often get process-based simulation models. So these are, as economists, we would understand these as structural models in the relevant science disciplines. So they actually have some kind of mechanical representation of the processes and causal mechanisms, but they give rise not to an economic quantity at the end of it. They give rise to a physical quantity, like agricultural, like crop yields, or deaths, or whatever. Okay? And this is just one illustration of that, so you don't need to concern yourself with the details of this. So, the enumerative approach. Going sector by sector and considering it to be reasonable to add up. In each sector, using natural and physical science studies and then applying prices to them. Okay? That's where the economist brings their expertise, just the price part of this. Okay? And thirdly, a lot of these underlying natural and physical science studies are using structural models or process-based models, okay, simulation models, which are somehow calibrated on the data. That's the essence of this approach. Yes?
And if someone disagrees morally about the value of statistical life, would that be an argument to kind of like say that this paper is irrelevant or doesn't actually capture the true value of the impact?
Yeah. I mean, and certainly many people do have moral objections to the concept of value of statistical life, in which case I agree with you, you are basically stepping out of this literature and you are saying that I don't think economic cost is an appropriate way to think about climate impacts. And we're going to think about that next week. But for now, just go with me. Okay? So I'm just a brief digression. So if we're using these process-based models and then we're multiplying them by prices, where do we live in the world of research methods? Well, I quite like this typology, which comes from an environmental scientist who at MIT called Ron Prinn. He distinguishes between experimental control, natural or quasi-experimental control, and numerical control. So experimental control is the world of lab experiments and randomized control trials, right? That is the sort of gold standard for causality, right? Because we get random assignment, treatment, and control, right? So in the social sciences, when we want to make claims like X causes Y, we would ideally use a lab experiment or a randomized controlled trial in the field. Often we can't do that for bad reasons and often for good reasons, like the Syria example. So we would then want to see whether the real world has given us situations which look like lab experiments. We call those natural experiments, right? And then we can bring our statistical toolkit to bear on those, or if we've just got like sort of two cases, we could do a kind of qualitative case comparison that would also fit within that mold. But sometimes we don't have natural experiments either, and actually climate change is the type of problem where natural experiments only get you so far. They could typically only generally pick off small parts of the problem. So then what do we have left? Well, we can build a process-based or structural model and simulate it. Right? That's a third alternative, which he called, I quite like this, numerical control. Okay? So the cause and effect is baked into the structure of the model. Right? That's how you get numerical control. And the use of the climate models in the Syria case, that was a case of numerical control, right? Because we were using structural models to construct both the counterfactual and the real distribution. So there's a bit of a digression, but I'm just trying to get you to position the use of process-based models in the kind of in the landscape of methods that we could use. We turn to simulation models typically when we can't run experiments and we can't find any relevant natural experiments. And I'll leave it at that. There's so much more we could say, but we won't. Okay, so that's all I'm saying about the numerical approach. Are you okay with that? You broadly get what I've said there? More nodding than befuddlement, so I'm going to take that as good. Yes.
So basically all these CMIP5 models, like the climate models we've been talking about in the last weeks, these are the numerical control models, like these structures.
They are process-based simulation models, yeah. I mean, if physicists were economists, and thankfully they're not, they would call them structural models.
Okay.
Okay, so now we're going to move on to the statistical approach. Okay, this is going to have quite a lot of similarities with what we discussed with the Syria case. Okay. So here the idea is to use observed data and try to link climate impacts to climate change statistically. I'm going to show you two different ways that this has been done, which are quite different in terms of what the source of identifying variation is. Okay. So the first one is an approach which essentially looks at the cross-section. Okay? It's become known as the Ricardian approach because it sort of reflects the ideas of David Ricardo, who's a classical economist. We don't need to sort of worry too much about this. The essence of the idea is this. So the original studies here worked on agriculture. So let's go with that example. Right? So we observe that farm productivity varies from place to place. Right? There are parts of our country, any country, where the farms are really productive. and there are parts where farms are less productive. One of the things that varies from place to place in a country is also the climate. So maybe the reason why a farm in this county is very productive and a farm in that county is not very productive is that the climate is better for agriculture in this county than it is in that county. So we're going to try to work out the role of climate change in farm productivity in this case by making comparisons across space at a given point in time. Okay? That's what I mean by cross-section. Okay? And we would do that by running a regression. And our regression might look something like this. So our outcome variable, it could be farm productivity, farm revenue. It could be GDP. In spatial unit I, that could be a county, it could be a country. And we're going to regress that firstly on a vector of climate variables. It could be things like annual average temperature, annual average rainfall, various other measures of temperature and rainfall and wind and speed and all sorts of things you can put in there. Right? See that this is written in boldface, yeah? Boldface C, that means it's a vector. Okay, and by vector I mean this is not one variable like CO2 in the Syria study. This represents typically a series of different climate variables. This is like the sum of temperature plus precipitation plus maybe temperature squared if you wanted a nonlinear relation. So that's that part, and then this part here, the xi is another vector, but this time of control variables. Right? And this is very important in the cross-sectional approach. Right? You need to try to control for the other things which would plausibly affect farm productivity, like terrain or proximity to a market. Yeah? Otherwise, we could be attributing changes in farm productivity to climate change, climate variables that are actually being confounded by other factors. Right? And then you've got narrative. So this is the source of identifying variation here is differences in climate from place to place at a particular moment in time. And we can contrast the okay. So and this has been extended from farms to think about bigger issues like, no offense to farms, but GDP. Okay, as for example in a Nordhaus tree, which is very nice because it has GDP data at the subnational level. And it was I think the first data set that had that. There are now some other data sets which have GDP at relatively fine spatial scales. Okay. The other statistical approach doesn't work with cross-sectional data. It works basically with time series, in particular in the context of panel data. Right? So if you're unfamiliar with the concept of panel data, think about it like this. So for the cross-section, imagine I had a row of observations, one for each country or county. Okay. Now, not only do I have that, but I also have a time series of observations for each spatial unit, each country or county. So I have a matrix, right? Or I have what they call a panel of data. And with a panel of data, I can do cool stuff. Yeah? In particular, I can use things called fixed effects to take care of all the other confounding factors from one place to another that don't vary in time, that could possibly affect the outcome of interest. Okay. So now I am regressing my outcome variable not only in, say, county I, but at time t. So this could be like Norfolk in 2026. I'm regressing it again on my vector of climate variables, each measured in spatial unit I at time t. I may have some control variables. Okay? There's a discussion to be had about bad control for the economists in the room, but let's not worry about that. And then I have these things. Okay, I have these fixed effects. This is giving each spatial unit I its own dummy variable. These things absorb all the time invariant variation in the dependent in the outcome variable, which is explained by that. I can have variables to represent time trends that are shared by either all the spatial units or by subsets. The bottom line, particularly if you're not trained in statistics or econometrics, right? The bottom line of this method is that we're no longer estimating the impact of climate change by comparing places with each other at a particular moment in time. We are getting it by comparing places with themselves at different points in time. So if you want to make this real, think about the difference in GDP between London and Lagos. Okay? If I were using the cross-sectional method, I would literally regress the GDP of London and Lagos on their climate characteristics and maybe some other control variables like measures of the rule of law, quality of government, so on and so forth. With the panel method, I'm no longer comparing London and Lagos. Now I am comparing London with itself. London in a hot year, London in a, well, like now, London in bad weather. Or Lagos in a hot year, and Lagos in a cold year. And then I am pooling the effects for all these different places and trying to get one overall estimate. The source of identifying variation here is very different. Okay? And when we get to the discussion a bit later this afternoon, I really want you to think about this. Because they do have strengths and weaknesses, these different methods, right? What am I really measuring when I compare places at a particular point in time, and what are the threats to identification? Versus what am I really measuring when I'm comparing places with themselves in different periods of time, and how long should those periods of time be? And what does that have to do with adaptation? Okay, yes.
One question about the statistical approach. So in 426, we talked about hybrid models as well. And how important do you think are they like currently in the literature? So for example, these long difference models, are they like getting more popular, or do you think like most like currently papers that are being published that they run basically just kind of fixed effect models?
I think long models this is quite an advanced question, right? So if you don't follow the question or my answer, don't worry about it. But so long differences models usually play out, and they are panel models. But are they cross sections where you're measuring differences? Probably better described as the latter. They are trying to. What should I say to avoid giving away the answers to the assignment? I'm not going to say anything. Let's come back to it. Okay, it's a great question, but I'm hoping this will surface. I'm hoping the discussion will surface these issues. Okay, so that's all I'm going to say about the statistical models. So we're trying to use statistical relationships between observed economic outcomes and observed climate variables to link the two. Okay? And we can do that either in the cross-section or we can do it in the time series. They're different sources of variation with different advantages and disadvantages. Yes?
Do we assume that the two vectors are independent?
Yes, you would need to. Well, I mean, there can be some collinearity between them. I mean, that's always a potential issue. They're unlikely to be completely orthogonal to each other, particularly the climate variables. You just have to hope that that's not too much of a problem. It's a standard statistical problem, though, I would say. Okay. Third method is computable general equilibrium models. How many of you have heard of CGE models? A few of you? Not many. Okay. If you've done macro, at some point you've probably encountered a CGE model. What are they? Well, I would sort of invite you to think of them in the following terms. They are a bit like the economists' equivalent of Earth system models. First of all, they are structural. So they are, in a sense, process-based. But we're not dealing with natural science processes here, we're dealing with economic processes. So we're going to try to describe the economy in terms of a large system of equations, which typically represent flows of goods and money between different agents in the economy. So they comprise households, governments, and firms. Firms produce goods which they sell to other firms and to households and to governments. Households give their labour to firms and also save money which supplies capital to firms, and so on and so forth. So we have this mechanistic representation of the economy. CGE model, I mean, there are other kinds of structural economic models, but CGE models are so-called because they are constrained by the concept of general equilibrium. General equilibrium means that markets are in balance. Okay, so labor supply equals labor demand, capital supply equals capital demand, supply of goods is equal to demand for goods, so we don't get big accumulations of spare people, goods, capital, and that sort of thing. So it's the idea of equilibrium, market clearing. That was the word I had a senior moment. Market clearing was the phrase I was looking for. And also, part and parcel of this is also the idea that agents maximize some objective. So households maximize their utility, and firms maximize their profits. Okay, that's their objective. So given these market clearing conditions, and assuming the agents are trying to maximize some objective, you can solve the model and give you an equilibrium. There is quite an interesting literature on whether this is the reasonableness of general equilibrium. Some of you might be aware. I think the two extremes of that debate are neither is helpful. Actually, I think it is a useful concept, but you shouldn't take it too literally. Households literally don't maximize. Firms may not maximize their profits all of the time, but it's probably a useful abstraction. Anyway, what can you do with models like this? Well, first thing to do is just to get a bit of history of economic thought, to understand what these models were originally constructed to do. They were originally constructed to simulate the effects of economic policies. For example, what would happen to the economy if we increase labour taxes or corporate taxes? Or, to pick a completely outlandish example with no relevance to the real world, what would happen if we increased tariffs indiscriminately? CGE models are really useful for this because, prior to bringing in the tariffs, we don't have observations of what would happen. These models were used a lot also in the discussion about Brexit. For a fat lot of good, the models did. They all told us it would be a terrible idea, but nobody was listening. Okay, so these models were originally used to simulate the effects of economic policy changes, but with some ingenuity, you can use them to simulate the effect of climate change as well. It does take some ingenuity because these models don't have climate in them. Right? The boundary of these models is literally just the edge of the economy. Okay? So you have to think about ways of doing it, but there are ways you can do it. For example, you can simulate sea level rise by calibrating changes to the stock of available land. You can simulate heat stress by changing labor productivity parameters, things like that. So simulate what would happen to the economy if people became less productive because it was getting hotter. That's a real thing, right? Heat stress and labor productivity is a big thing. So you can simulate these kind of things in CGE models. And you can basically look at principally the difference between the equilibrium without climate change and the equilibrium with climate change. It's a little bit like the Syria study again. So making a comparison between two equilibriums. The model might even be a bit dynamic. These models are not brilliant at dynamics, but you can also potentially trace through the journey from one equilibrium to another. A few hands going on. Yes.
This isn't informed at all by actual economic behavior, it's only economic theory, or there's some like alignment between like observed.
That's a great question. I'm going to answer that in two parts. The first thing I'm going to say is that these models are calibrated on data. I think your question is alluding to assumptions around maximization, probably. That is an assumption. And you know, the body of behavioral economics, for example, tells us that people aren't actually great at maximizing. But that leads us into a discussion about what, I mean, when you build a model, you have to abstract, right? You have to simplify. So if you're not going to assume that people maximize an objective, like utility maximization, which basically means satisfy their preferences, then what instead are you going to assume? And how generalizable would that be? My take, for what it's worth, is that yeah, households don't maximize utility literally. Firms are probably more likely to maximize profits, but again, probably not perfectly, but both households and firms go in that direction, right? So you still learn something from both the direction and the size of the effect. But yes, you are, you know, we are building a model out of economic theory and calibrating it, which is very analogous to what physicists do when they build Earth system models. They build models out of physics theory and calibrate them. The difference is whether we think that the economy is subject to the same kind of immutable laws as the natural environment. And on that, big books have been written. Yes.
I was wondering, how do they relate to those typical systems dynamics models? Are they a form of that? Like, for instance, the limits to growth models, are they a form of that?
These, that tradition typically doesn't assume equilibrium, right? So they're very, that sort of literature very explicitly doesn't want to assume equilibrium, which has some advantages. The disadvantages with those models is that you can write down any relationship that you think, and then just run it. There's nothing to condition these models or constrain them.
And then basically, does this equilibrium mean that essentially they're static and like they stay the way they are? Or can you also simulate with them, okay, you have like a shock to the system, and see how they...
You can do dynamics with them, but they are... You see, these models typically have like 50 sectors, and sometimes 50 sectors in like 20 countries. And so you can't really do full dynamics with rational expectations and so on and so forth. You generally have to simplify a bit. But the simple point is that you're not limited to just comparing one static equilibrium with another. You can look to some extent at the journey from one to another.
Just very quickly, I feel like I always hear about these in terms of trade and policy.
Yes.
So are the game theory models part of the CGE ones when you're trying to game theory models when you're trying to understand different strategic?
They would not. They would not have this kind of detail. These models are built for quantification, And they're built for, usually for simulating particular trade scenarios rather than for calculating optimal behavior in a game. Right? Because once you have a model with this level of detail, it becomes very difficult to do things like computing Nash equilibria, that sort of stuff. So the game theory models tend to be way simpler. Yes?
Just following on the last question, if climate enters as an exogenous shock, right?
Yes.
Like how we use other structural models like ESGE or HAC, because it's like cost push shock and you enter into it.
Yeah, you can do that too. Yeah, I mean that literature is kind of brand new. There's not much of that going on yet, but these you can do that too. That's a class of model that I've put outside the scope of this lecture. Okay, so but if you've heard of DSGE, dynamic stochastic general equilibrium models, then yes, you could think of putting climate shocks in those as well. Okay, so that is what I wanted to say about CGE models. Okay, so they are process-based or structural, but they are the economist's equivalent of an Earth system model. They are theoretically informed, but they're informed by our laws of physics, our equivalent of the laws of physics, our laws of economic behavior. We then take that theory-driven structure and calibrate it on a real economy and use that for simulation. Last method is much simpler to explain in some ways. It's expert elicitation. Okay, so let's not build a model. Let's just go ask people who know a lot about it what the impact of climate change would be. And you know, I obviously I'm being flippant. This is a respectable, widely used methodology in the sciences and the social sciences. Okay? And there's one paper on your reading list which applies it. I've also recently published a paper with some colleagues where we did an expert survey, but let's discuss this other paper. It's a bit simpler. What are the steps in this method? Well, they're pretty intuitive. Firstly, you need to define an expert, okay? Which is kind of an interesting step, right? Very often, the way that this is done is to say that the set of experts on this topic is a set of people who have published papers on this topic in peer-reviewed academic journals, which is a reasonable approach. But it can also naturally be subject to false positives and false negatives, right? Because you can have some published papers. Well, first of all, you can have some published papers which are just bad. Also, you can have published papers that are good, but have large author teams, some of the people on which are just there because they're friends with the lead author, or they raised the money for the project, or they did a small piece of the project and therefore don't really know that much. And that's possible. And we can also get false negatives, so people who've thought deeply about the issue, know all about it, could give you a very sensible estimate and for one reason or another just didn't publish a paper on it. So those are the problems, but anyway, this is probably quite as good a way as any to do this. We then send each of the experts a questionnaire survey. Okay, so thinking about social science research methods, we're in the realms of questionnaire surveys. Although these types of questionnaire survey are in many ways sort of simpler and shorter than the kinds of one that you'd send out when you're doing large sample social surveys of the population. Receive responses, analyze responses. So here's an example. So this rather dense slide is actually like a screen grab from Bob Pindyke's questionnaire. So he asked his experts 3 questions. Well, there must have been more, but question 1 was, I don't know, what's your name? So question 2, though, sort of probably the most important question for our purposes. So under BAU, what does BAU stand for? Business as usual. That's an important acronym to remember in the climate space. Under business as usual, which is, by the way, a more complicated concept than it used to be. But anyway, something roughly like no more action in climate change than we're currently taking, or no action on climate change at all, depending on how you want to interpret it. What is the most likely climate-caused reduction in world GDP we will witness in 50 years? In other words, how much lower in percentage terms will GDP be in 2066? Right, you did this questionnaire in 2016, hence the random year, compared to what it would be with no climate change. So the experts were asked to put a number on that. That was question 2. Question 3 is a similar question, but it's trying to get trying to get more in the direction of quantifying the uncertainty about the expert's best estimate. Or in other words, get the expert to provide enough data points to estimate a distribution over that expert's estimates. Okay, so Bob asked asked his experts to state the probability of a 2% or greater reduction in GDP, 5%, 10%, 20%, 50%. And then question 4 is basically like question 2, but the time frame is much longer, it's 2150. So these are typically the kinds of questions that you'd ask in an expert elicitation.
Is the researcher expected to do additional research to answer the question, or is it just based on what he already knows, based on what he's done so far?
So there's no, you're not doing these under like controlled conditions typically. So you get an email that says we're doing this study, we'd like you to respond. Some people will just do it pretty quickly, just based on what they know. Other people will kind of stop and think about it, maybe have a look at some papers, whatever. So it's going to vary from participant to participant. If you're being sophisticated about this, your questionnaire software will be able to measure things like response times, and you can control for that.
You can be an expert in the field, but like surely some just goes GDP will also be like this, and probability 20%, and like
I don't know what you mean. That doesn't sound like a professor to me.
So it seems like if it's off on his head based on what he's done, like it seems like he's.
I mean, let's surface these issues when we have a discussion about this. But like, there's a discussion to be had about how seriously we should take these numbers.
What sort of sample size do you tend to aim for with something like this?
So for our study, we had 68 responses, of which 48 were complete. Out of we asked about 170 people. Bob's numbers would have been, I mean, it'll be in the paper, I don't know, it'll be similar. Sure. So these are small samples, okay? But then
But that's reflective of how many experts there probably
170 in our study was the population of experts.
Yeah.
Right? That was the sum total of all people who had published a study on the thing we were interested in over the interval we were interested in.
Right.
So there's a hand, I saw a hand, great, yes, and then I'll come back over to you.
Any consideration as to how the questions were phrased, whether you'd get different answers based on the phrasing as opposed to kind of...
Yeah, I mean, not in this study, but people who actually write on expert elicitation as a method think a lot about this. And in our study, which I really should put on the reading list, for example, we were interested in something called social cost of carbon, the marginal damage cost of CO2. We first asked the experts directly, what do you think it is? Then we asked them, however, a menu of questions about what do you think a good model looks like? And then we used that to produce a rival estimate based not on their answer to the direct question, but sort of building it up indirectly. So that's one example of how you could do that. You can also like change the framing, and you could do like you could do random treatments on subsamples of your experts. Like you could change the way the question's asked. You could do all that. Bob just wasn't interested. Yes.
In this model, how do you handle or adjust the outliers?
That is a choice. We'll actually see when we see the results of this study, we will see that there are some very strong outlying experts. And then you basically, it's your judgment as a researcher whether you want to produce a mean estimate, including all of the estimates, or whether you want to cut the outliers or Winsorize, the usual methods that you would have for dealing with outliers. No different to a normal statistical problem.
So with the expert illustration method, we face similar issues like with contingent valuation for CWTA, WTP. We face those kind of issues with.
Yeah, as a general comment, I would say that the contingent valuation literature is more sophisticated about its questionnaires than expert surveys. But I mean, hypothetical bias is not an issue here because it's just a different problem context. You're not asking a question about how much you're willing to pay and hoping that that's what they're really willing to pay. You're just asking them what they think about something. But some of the other sources of bias, like anchoring bias or sort of framing biases, are also relevant here. So because contingent valuation is also a questionnaire-based method, they do share challenges and solutions. Okay, I'm going to propose to take a break, take the second 10-minute break now. You can read this in your own time. We'll start again about 5 past with the next group exercise.
I've got to go walk. Two classes. It's not even a lot of space. Yeah, I think sorry. I like looked at it and I was like, maybe like 10 minutes later, I was like, okay, wait. I don't think there would be a scenario where it's knowing if I was all your hours. No, and to just like, I'm gonna take I know, but I wasn't gonna. That's like, you like to know. Yeah, I totally, like, I think the person was, and then, is it like, yeah, this time I didn't understand. I mean, that's it's kind of a yeah, some senses, but for some people it looks like shit. Like imagine your yeah, I just no one
Not so much for but like you have to get into classes and your dissertation.
I was thinking you're talking about
Yeah, exactly.
Pero si está teniendo acá,
I know.
The environment didn't like yeah, sure. I think that's what it is. I think that is what it is.
What's going on?
But yeah, I think that's what it is.
No time to I know.
There was
Someday I make them.
someday
I'll make them. I'll bring them in here.
Like they're not prospects.
I know. Tell you we're in like that's
I feel like when I first woke up, I realized
That is also funny.
You put this on
damn, you can stop it on its own.
I had a signature.
Yeah, exactly.
Like whatever, and I was
These are so
that's a policy. That's awesome.
and then my sister, yeah, I know. That's why I don't
For us, like,
I was in like a morning thing, so it's like sour cream and cheese. They don't have like flavor.
I think it's get verified or whatever.
But like, but it's so
I don't think so. I think it's just that there was no like.
Various travels. You know anything?
Yes, I was in Singapore.
Some way of like this is
Okay.
meant like a
But that's what I praise again.
Yeah.
It was good to be back. Yes, yeah, I went to Norway. No, but it was really lucky to see like how was your trip?
Very adventurous. I was in Spartanburg.
So it always is.
Yeah, so I'm Irish as well.
I know well.
Which part of
They're speaking English. I know. I'm not gonna say anything. Like, yeah, great.
Oh, okay, wow.
In my area.
How are they doing? But I'm glad you guys said it. It's just like pure vibes. Such a funny guy. I'm going to tell him that.
Yeah, I've been like a few years ago to Glasgow. I went to Isle of Skye.
It's fine. I had it.
but we didn't try. But
Yeah, I was so you still look so nice, but I'm like, but I'm going to
That would have been perfect.
I'm like,
and some of, you know how they have the VIPs who like aren't connected to the team, sit up there or whatever. There was a show. Like, and like, you know, like no empty seats for the camera. So they just brought me down. They're like, so how do you know? I'm like,
alright, yeah. I have no idea what's like a mobile when it's the first week, right? So something else.
what do you want to say to them then?
I really miss the first half now.
Alright, thank you. So I'm going to get you started on the next part, which is discussion with your colleagues, so you can keep chatting, although hopefully you'll actually talk about the exercise. Okay, so it's really quite simple. I want you guys to reflect with your neighbours on the methods that I've just described to you and try to think about the strengths and weaknesses of them. Okay, for about 10 minutes. And then after that, we're going to come back together and we're going to have a discussion all together about the different strengths and weaknesses of these methods. So 10 minutes with your neighbours, try to go through each of these methods, think about one strength, one weakness. Okay, so off you go.
There is something nice about it.
They're giving like At the first one, like after like one turn, I'll be like, yes, yes,
You were right. Nice of it's just like yeah, it was just how and then you go through ways so I just find like very
I'm not paying you. I just want to do a support, maybe just
But you're also actually you only get back 30 results. Not like 68 people. Say something.
sorry, Monday. There's something that money house
I remember there were a lot of uncertainties. That makes sense, like some expectancy. Like, I'm sorry. We're all sorry.
approaches that has like
He's obviously an expert.
Yet another reason to hate this room.
the others actually tries to put
2 minutes, 2 more minutes.
Create space. Just like it's
I know. She's like an hour.
usually, I mean, it's just experts.
Oh my god. I just showered.
Let's wrap it up. Okay, so we're going to see whether we can identify some of the strengths and weaknesses of these different methods. So let's see what you've come up with. So let's go through them one by one. So the enumerative method. Let's try and think of some strengths. What did you come up with?
Relative ease of application.
Yeah.
More or less straightforward to just count up and then put together an applet.
Yeah, I think it is sort of clear. It is relatively clear and transparent. I mean, it doesn't sort of transparently shine a light on the underlying natural science studies, but as far as what the economists do, it's pretty simple. And you know, that is always good. In and of itself, we like simple methods that are clear and transparent. Yes. Yes.
We talked about the kind of access to quite a diverse literature. So if you're looking at agriculture and looking at tipping points and then looking at health, you can kind of dive into lots of these kind of pockets of research that's been done. You're not kind of constraining yourself to only looking at economic analysis.
Yes. That's really good. So I'm going to use your point to make two. So one is that you can essentially leverage natural science knowledge, right? So we're not reinventing the wheel here and pretending that we're better than domain experts in doing the thing, although, you know, the economists have had some successes in this area, but we're leveraging natural science knowledge And we have a method that is relatively easy to extend to things like non-market impacts and potentially things like tipping points that are potentially important, that are at the outer edge of what is easy to deal with in economic models. So, it can be extended to let's say non-market impacts, and you'll know what those are from the video. Potentially tipping points, so I've done some work trying to do exactly that, and so on. Yeah. That's good. I think those are some of the most important strengths of the enumerative approach. What about weaknesses? Yes.
So we were thinking it might be a bit static. So there might be between sectors there might be synergies which increase the costs or decrease the costs, which are not accounted for.
Yeah. So I think one of the big worries is with the enumerative method is it ignores interactions between sectors. So we might have the health sector where we're looking at the effect of heat on health, but what happens if that's happening at the same time as food security problems are happening? These could interact with each other in complicated ways. Yes. Did I see a hand up over?
Okay, it assumes that elasticity stays constant with the change in price.
Yes. I guess it does. Yeah, so it tends to use fixed shadow prices, I guess you would say. I mean, you can actually, you see, if you were doing a good study of, say, health impacts, you would probably link the value. You could link the value of statistical life to income. Right? So some people think that's a desirable property because VSL does scale with income. Other people think that morally that's not a desirable property. So I'm going to roll back on that. You can actually include some important elasticities. Yes.
Maybe it goes a bit in the direction of the first point, but there could be double counting between the different categories.
So basically this whole idea of doing this on a sector by sector basis and just adding up leaves open the possibility that you're either double counting or you're missing gaps that are because you're not dealing with the interactions between sectors. Yes, absolutely. Yes.
I think so. This is an issue, maybe all of the methods, but specifically the fact that any numbers or data gotten from that study is only applicable to probably the area where those sector-specific leaders are. Because, for example, what they value a tree in Nigeria is probably different from what they value it here. So I feel like if they give those numbers, it's only specific to the area where those numbers are gotten from.
I think I heard you say external validity.
Yeah, external validity.
So, I mean, this is an issue which I think is not, as you say, is not unique to. So I'm going to put it over here as a worry that we would always have. So external validity, extrapolating out of sample, however you want to think about it. It's a problem to a greater or lesser extent for all of these models. But yeah, I think that I think these are two of the most important weaknesses of the enumerative approach. So I would be happy to leave it there, except that I would worry about also just about incomplete coverage of sectors, right? So it's just even if we ignore like interactions and double counting, it's just very difficult with this kind of bottom-up, like sector by sector approach to actually include all of the many impact pathways that climate change has, right? So some of the other methods are just potentially better at dealing with that, right? And you know, you can try and deal with that by just throwing in more sectors, but at some point it's just going to be, it's just hard. Yes, sorry, you had your hand up.
Also in relation to the extravalidity point, is the value of, for example, specifically biodiversity. So how do you solve that issue? How do you account for the value of that in this?
Well, you would use shadow prices. For biodiversity, they might come from something like contingent valuation, and let me just stop my computer from firing off. Shadow prices can be unreliable, is what I was going to say. So, you know, value of statistical life, for example, so that's one of the most important shadow prices. Shadow price meaning a price that doesn't really exist in the world, but that we infer. There's a lot of uncertainty about that. There's also a lot of uncertainty about shadow prices for things like species or ecosystems, yes. But at least I would say that, you know, at least this method, at least there's relatively straightforward to extend to non-market type impacts. You had your hand.
I guess like on the concept first of like external validity, isn't for the strengths of all of them, it's just it's better to try to put a number to the costs of climate change than do nothing at all.
I would agree with that, yes. But it is a point on which reasonable people can differ, right? On whether a number is better than no number.
Why would that be? Like, what's the rationale behind like no numbers?
I think some people would say that, you know, you're never going to come up with a reliable estimate of the economic impact of climate change. I don't think you should be using economics to analyse this issue. We need other decision frameworks. For example, we should think about climate change as a question of human rights. We'll touch on that next week. The objection would be, objections could include, well, you know, economic reasoning is normatively important. Another objection would be that money makes the world go round, so if you don't estimate these things, people will just ignore it. These are the kinds of arguments given on the other side. I want to make sure we've got time to discuss all the methods. So I know I've had some hands coming up and down, but I want to move on to the statistical approach. So advantages of the statistical approach. Yes.
It leverages existing econometric literature and methodologies.
Yeah. So you know we're leveraging you know sort of established causal inference methods like panel data regressions. And you know. Climate variation is on short time scales and at scales below the globe. Climate variation is beautifully exogenous. Right? The climate system has a lot of internal variability and sort of chaos in it. So over short time scales, the changes in climate conditions from one year to the next, they're as close to pure randomness as you can get. So for an economist, this is like a dream. Right? This is why we just, a panel regression with fixed effects and the time trend is just usually perfectly good, right? Don't need anything fancy with our regression discontinuities or instrumental variables, or I don't know whether these things mean anything to you, but fancy econometric methods, right? They're not necessary in this case. So yeah, we have sort of beautiful causal situation here. Yes.
I guess as a strength and a weakness, it's interesting to causally isolate like one variable like revenue or GDP, but not very holistic or interactive as well.
Well, that depends on the choice of the outcome variables, doesn't it? Because you can do statistical studies at multiple scales. You could use it to study something like crop yields, in which case you would kind of be almost in a situation where you were doing the enumerative approach just with statistical methods in each sector. So you could start to think about hybrids. But if you run a regression of country GDP on climate, you are doing something much bigger and potentially capturing a much bigger set of mechanisms.
But for like non-market impacts, like tipping points or health, can you still?
Yes, I think it's hard. I mean, you. Yes, I think that's complete. I think we can keep it so you can start to think about ways to hybridize these methods, but let's keep it simple and say that it is hard to study non-market impacts, etc. And the reason for that is, of course, that the statistical method works with observations, and we don't observe the economic impacts along the non-market channel, by definition. Yes.
Another weakness would be that sort of we say that past data is a good indication of future data, and like we have never pushed a country more than like 2 degrees or like more than a certain level, and we will do that in the future. And we, for instance, we still say, okay, this past increases are a good indication for how the GDP will behave.
Yeah, I agree. So external validity can be a particular concern here because we're relying on the estimates we obtain from historical data to be applicable in the future. You know, views do differ on this. So in some sense, it's obvious that we're moving globally into a climate regime we've not been in the past. That is obvious, right? And at least in human history. But on the other hand, some of the defenders of the statistical approach would be to say that, yeah, but you know, around the world, we've got such a such variation in climates from like Dubai to Singapore to Ulaanbaatar to La Paz, you know, that actually we're often really in some, if you think about it from that point of view. But I think it's a very fair point, yes. And it's something which the more simulation-based methods have got potentially a better answer for. Yes.
I think that other weakness will be the specification issues, like how we specify the data and the function is very arbitrary, and we lack the different types of specifications.
And we'll talk about this when I just do the next mini lecture, but it turns out that these studies are often quite fragile to minor specification choices, right? It's one of the totally infuriating aspects of this literature, where one study will give you one result, and then another study, which seems on the first glance to be exactly the same, will give you a completely different result. And it turns out because there's like a difference in the nth order polynomial of the time trend or something, and then you're like, what the fuck? That's my technical term. Yes.
For the panel data approach in this context, wouldn't it be assuming that like by comparing a hot year to a cold year, it's assuming that sort of short-term difference would then carry over?
Wonderful. Yes. So the panel approach, which is the better approach for dealing with not omitted variables bias, clearly, right? The panel approach assumes short-run fluctuations are indicative of what might happen in the long run. And this is where adaptation comes in, right? So I was asking you to sort of hold that thought, that this is exactly this issue, that you've got this kind of trade-off. So the cross-sectional approach is great at thinking about adaptation, because if you're comparing places at a given point in time, we could argue that, roughly speaking, each place is kind of in equilibrium with the climate it's had for ages. Okay, it might have changed a bit, but it's still like a farm. You know, like a farm. A farm is the way it is because it's adapted to its climate. Otherwise, it wouldn't succeed. But on the other hand, the cross-sectional approach suffers from this big problem of omitted variables bias, very difficult to control for everything. The panel approach deals beautifully with the omitted variables bias through the fixed effects and the time trends, right? But it has, because it's usually identifying variation of year-on-year changes, there's not a lot of adaptation you can do from one year to the next. I mean, you can't change London into like a water world in like, you know, if the Thames floods. But, you know, given 50 years, maybe we can look like Amsterdam, right? You know, or you know, if you've read New York 2150 by Kim Stanley Robinson, a slightly more dystopian vision of a flooded city, right? I don't know if any of you have read that book. Have you? I really recommend it. It's a wonderful book.
Is the fragility classification a weakness? Is that meant to be a weakness?
Yes, sorry, it is. Thank you.
I just wanted to make sure
I was so excited about that point. Okay. I need to manage my time a bit. So the long difference is
I just wanted to ask, do you see like a shift in
a way to compromise between these things? So this is more like a cross-sectional regression, but what you're regressing is differences. So you're essentially doing a kind of differences in differences approach. With long differences, you often you compromise a lot on the amount of data you've got, and then you can have problems with statistical power. But it does go in that direction, is what I would say. I need to talk about that more in office hours or whatever. Okay? I think we need to move on. I want to just check that I've got everything. So, I mean, like, I really want to emphasize that something that's great about the statistical approach is it's data-driven, right? And like a lot of these process-based models, whether they're science models or economic models, there is just a basic worry about like how well calibrated they are and if they really are a good representation of reality. And with, the statistical model is just very rooted in real data, which is what makes it very compelling in many ways. Yeah, okay. CGE models, strengths and weaknesses. What would a CGE model be good at?
It accounts for the interactions in the system.
Indeed. So whereas the enumerative approach ignores interactions, the very nature of the CGE models is that, I mean, they're all about interactions. So not only do you include the interactions when you've got a CGE model, but you can actually explicitly study them as well. You can quantify not only the first order effects, but the higher order effects, okay? So that is a key strength of them. Yes?
Would a weakness be that they're relatively black box, less transparent, as opposed to even the statistical methods that, if you know your independent and dependent variables, there's transparency there?
Yeah, they are. I think, any of these kind of high complexity structural models have this problem of being, to some extent, black boxes. Same goes for physical models.
Does it use sort of real world previous data to sort of predict what is expected?
Are you asking?
No, it's a question.
So these, typically these models you write down, as I tried to explain earlier, I may not have done it well. The structure of the model comes from economic theory, and then you try to calibrate it on the real economy. So you assume the starting point is a good representation of the real economy. But I do think that is generally, let's say, dodgy calibration. It is that's another technical term. That is a known issue with CGE models. Okay. Yes.
If you would look at models like VAR models, then you could actually look at the dynamics of a change. What would
I wouldn't include VAR models as CGE models. They're more statistical in nature. Yeah, I don't know which order, but yes.
Okay, I would say that other strength is that these models are very good for scenario analysis, so we can account what are the fiscal or the monetary impacts of particular climate shock.
Yeah, they are well suited to scenario analysis. They might even be quite good at stress testing, right? So that's a particular subset of scenarios where you put some really big shocks. So e.g. stress testing, so you put some really big shock on the model and see what happens. That's quite, that's quite helpful in things like macro-prudential policy, like the finance ministries and central banks do. Yes, notwithstanding the weaknesses of those models. Yes.
Yeah, one constraint is rep agents.
Pardon?
Rep agents.
Representative agents. Yes. Yeah, sure. So I mean. Yes, let's put those under the general bucket of aggregation biases, shall we? Because this is quite a special case of that. Basically, these models, they don't, you can't model all the households and all the firms in the economy. Again, I put that in there, so I should go over here. You have to simplify so you end up with a representative agent for each economy, each sector, and so on and so forth. Okay, I've got an eye on time. Let me just see if I've captured everything I want. I can share these later, by the way. These are my teaching notes, but they'll probably be helpful for a bit structural.
Is that also just like all of the assumptions are quite heavy, which kind of fits under like calibration, aggregation?
So yeah, they're slightly different points. The aggregation bias says that if only I could build a model which represented every household and every firm, then my equilibrium assumptions and my maximization assumptions would be fine. Whereas I think you're wanting to actually talk about the legitimacy of the equilibrium and the maximization assumptions. And I think that some people see it as a strength, that these models are constrained by economic theory, and some people think it's a weakness. So I'm just going to put equilibrium right across the middle. As either a strength or a weakness, depending on the way you think about it. Okay? What I want to develop the point about interactions, though, is I do want to stress that among the interactions that are interesting in CGE models is adaptation, right? So you get, by the very nature of these models, you get a form of market-driven adaptation. Okay, so you put a climate shock into the model, you'll, for example, change the relative prices of different goods, and firms and households will adjust their purchasing behavior depending on what's become more expensive as a result of climate change. Yeah. So it explicitly represents adaptation. It's very good for studying this particular form of macroeconomic adaptation. They're not great for studying project level adaptation, like building seawalls and things like that, but they are very good for thinking about, if you shock the economy with climate, how much can we expect it to adjust just through the price mechanism? Basically, that's the essence of it. Okay, I want to do expert elicitation now so that we've got a little bit of time left for the final slide. So what's good about expert elicitation?
It leverages domain expertise.
Yes. Yeah. So this is going to leverage. And why might that be particularly useful? Under what circumstances could expertise tell us more than these other methods?
I mean, when you want to stretch beyond sort of numeric data and get some other relationships into it, it can be valuable to have those inputs.
Yeah, so we might use the Rumsfeldian known unknowns, right? So one of the ways, when you ask experts to give their best estimate of this thing, they're probably going to be informed in part by the literature they work in, what the models say, but potentially their responses are going to factor in a subjective estimate of the stuff that's not included in the models, or that might be biasing the models, right? So this is the only method really that I know that could factor that in.
Also for like the public, it's quite easy to understand more than.
Well, yes, it's clear and simple. In the contemporary world, unfortunately, expertise is sometimes a disadvantage. There are large chunks of the population who don't trust experts, so that can be both a strength and a weakness to be able to say that I got my number from asking experts. You could get the kind of experts, they're just socialists, aren't they? Kind of response. That's it cuts both ways. What would be the weaknesses of expert elicitation?
how you define your pool of experts, and related to that, there might be some kind of selection effects as to who actually responds and what kind of incentives they have to be truthful or not.
To get sample bias. So, for example, if an economist does a survey, the experts include both economists and natural scientists. The economists might be more likely to respond because they recognise the language or they have some personal relationship with the person doing the survey, so you could get sample bias, yes. I mean, I think you could, there are obviously ways to deal with sample bias, right? Sort of with weighting according to the characteristics of the respondents, but yes. I don't know who had it, you had your hand up.
I think it might be a bit difficult to trace how the experts arrived at their conclusion.
Yes, right.
With the other ones, you can like change the parameters potentially and then know what impacts it have, which you cannot really do.
So the expert opinion itself is a black box, isn't it?
Yeah.
And experts, just to wrap up, because I'm quite tight on time, you know, the experts, although they're experts, they're also subject to framing effects and biases and all the sorts of things that we worry about when we ask so-called non-experts to fill in questionnaires, you know, like the old thing about, you know, people being more likely to agree to a health procedure when they're told what their probability of survival is than when they're told what the probability of dying is, even though it's exactly the same probability, it's just how you frame it, right? So experts are actually not immune to this kind of thing. So we'll just call this response biases. Okay, that's a really good list. And as I said, I will put my notes on Moodle as well, so you've got some additional points and some structure on this. But what I want to do in the last 10 minutes is I want to just quickly go through a slide set basically describing the results of this whole literature. It's going to be quite quick because we're quite tight on time, but that's okay. So, yeah. So I'm going to do this this story a bit chronologically. I often find it's good to explain stuff in terms of the history of thought on an issue. So I'm starting with the literature up to about 2013, so we'll call this the old literature, which was gathered together in a paper by Bill Nordhaus and Andrew Moffat. What you can see here is the global economic cost of climate change as a function of temperature increase. I want to stress two things. First is that the numerator here is global GDP, but depending on the method you're using, these studies are not literally trying to measure changes in GDP. Sometimes they're measuring a broader conception of cost and then just expressing it as an equivalent reduction in GDP. Okay? Because you'll know that GDP, as all good, well-trained economists know that GDP is not a perfect measure of human well-being. Okay? Some methods literally use variation in GDP to try to estimate the impact of climate change, but other ones step outside that framework and think about, for example, non-market impacts. But then you need to express this as a number that people could understand and relate to other things. So the exam question becomes what reduction in global GDP would be equivalent to these costs, right? So I just want to stress this. We don't need, at this point, to get into a discussion about whether GDP is a good measure of human well-being or not. You can have fun in GY427 and other courses on that. It's only marginally relevant here, okay? So with that, a second point I want to make is that whenever I show these sort of data to people, you know, many people have the visceral reaction, sort of like, okay, 2% of GDP for 2 degrees of warming. Is that all? That's nothing. I think climate change will cost 70% of global GDP. Right? Both of those answers are possible. what I want to stress is that it's very difficult to get your head around the enormity of global GDP.
Yeah.
Right? You don't need very large changes in global GDP for climate change to be a big problem. Global GDP in real terms just keeps going relentlessly upwards. It's hardly been moved, even by things like world wars, financial crises, and pandemics. Okay, so you sort of, you hear this a lot amongst the environmental lobby that these results are clearly ridiculous because climate change is going to completely wipe out the economy. That is possible, but it is not necessary for climate change to be a big issue. You only need to move global GDP by like 5 to 10% in order to want to keep warming to below 2 degrees. I'll show you next week how I do that reasoning, but for now, I just want you to think about these numbers as not necessarily being tiny. Okay? Right, so some stylized facts of the literature. The old literature, the old literature you would get some studies that would say climate change is good overall, but most studies saying climate change is bad overall, and you would generally see that it gets worse the hotter it gets, as you would expect, possibly non-linearly, right? But there are very few estimates out there for very large amounts of warming, so it's very difficult to constrain the relationship when you get out into this territory of a 4-degree or a 5-degree warming. Okay? I had a couple of slides just making that point, but I'll run over them. And I will bring us straight up to closer to the present day. So this chart is virtually the same as the chart a few slides ago, but just with the axis flipped, okay? So in this slide, down is bad. And in this chart from the IPCC 6 assessment report, up is bad. Okay, it's just like multiplying the y variable by -1. Yeah? Okay, so up is bad. So this is a picture as of about 2022, and you can see that now studies are starting to emerge, primarily from the statistical approach, suggesting that the impact of climate change is a lot larger, right? Including this famous Burke et al. Study from 2015, which I talked about in the video, in mini lecture 3.2. That's starting to give us numbers like 2 degrees of warming might cost us 10, 20% of GDP. So really large numbers, okay? So really large numbers coming primarily from the statistical approach. Okay? As illustrated quite strongly when we break down that chart into different methods. So you can see that structural models, that's essentially CGE models, generally giving much lower numbers than the statistical studies, particularly some of the statistical studies. Okay? So essentially the econometric or statistical literature comes along in the 2010s, riding off the back of the empirical revolution in economics more generally, where economists flocked towards empirical and econometric methods, and seemingly really changing our understanding of the magnitude of the economic impact of climate change from something like 2% of GDP for 2 degrees of warming to 20%, so literally an order of magnitude. Okay. And everybody got really excited about this, right? For good reasons and for bad reasons. The trouble with the statistical literature, as you mentioned in the discussion, is that it turns out to be fragile, right? It turns out that you can run 2 studies on the same data with almost identical regression models and generate very different outcomes. One of the main reasons why this is possible is the issue of the persistence of climate impacts on the economy and how that plays out over time. So one of the biggest issues in the climate econometric literature at the moment is whether climate change impacts the level of GDP or the growth rate. Okay? If it impacts the level of GDP, then a one-off climate shock, a hypothetical one-off temperature shock, will just temporarily push you off your long-run growth path. Okay? But if you write down a model which says it's the growth rate of GDP which climate change affects, then you will, even a one-off shock will permanently shift you onto a slightly lower growth path. And now if we think about not just a one-off temperature shock, but a sort of step increase in temperature, then the growth effect will compound over time and end up driving you onto a completely different economic pathway. And the Burke et al. Study that gave you all these green observations here, that was based on a model of growth effects in green, whereas other studies, I think, for example, Khan et al. And Kalkulu Mintz, roughly speaking, they have a model which is more like a levels effect, so they're using the red model. And these models are very similar. They're just, one of them is using the level of GDP as the dependent variable, the other one is using the growth rate. Everything else can be the same, and you will get a difference this large. So these new estimates have come along, and they have definitely changed our reference point, made us think more about the possibility that climate change could have double-digit % impacts on GDP, even for like 2 degrees of warming. But it turns out that it depends sensitively on issues, most of all on this issue of the persistence of climate impacts on the economy, right? Whether the economy has a long memory for shocks. Okay. So, you know, one thought experiment I often ask students, is a bit of a parochial one, I admit, is that 1984 was a very hot year in the UK. Do you think that the UK economy in 2026 still bears the marks of the heat wave of 1984, 42 years ago? If you buy into the growth model, the answer is yes. If you buy into the levels model, the answer is no. There are models in between those two things that we can think about as well, though. For example, distributed lag models, or we could use a local projections method or something like that. So it doesn't have to be in the two extremes. Last thing I'm going to show you, because I'm almost out of time, I'll show you what the results of Pindyke's expert elicitation study were. It's a slightly complicated chart. I mean, he doesn't present his results in very kind of intuitive ways. But, I mean, basically Pindyke's experts were pretty pessimistic in the sense that they thought large impacts on GDP were possible. So, on average, his experts thought that a 20% loss of GDP associated with 3 degrees of warming was about 26% likely, so a 1 in 4 chance of losing 20% of GDP with 3 degrees of warming. That is bringing you into the ballpark of these econometric studies, right? So here's a sort of a somewhat independent estimate, also suggesting large numbers for the economic impact of climate change. I mean, there's a difference between large and very large numbers. But a feature of Pindyke's data, to your question about outliers, is that most of his experts were clustered around thinking that the impacts of climate change would be very modest, and his average effect is very heavily driven by this tail of super pessimistic, you know, Professor Doom is down here, right? Sort of, you know, woken up after a heavy lunch at the faculty club, looks at question 2 of Pindyke's survey and says, it's wipeout, everything is wrong, right? And so we have to decide what we're going to do about these outliers. Okay. All right, it's time to wrap up. You have the summary slides, so you can read those in your own time. I will see you next week. Please don't forget to prepare for next week. Everything is up already. I may or may not remember to send you a reminder email. Even if I don't send you a reminder email, there is stuff to prepare. Okay? See you next week.
I don't know why I skipped a meeting. Fair enough. How are you doing?
you gonna go to the top?
Why are you doing this to yourself? She will.
Next week I do.